Okay, now for this lecture, we're gonna deal first with direct lighting, and the difference between the two, between direct lighting and diffuse lighting, is how how light falls on the object. As you can see here, on direct lighting, there is a distinct separation between light and shadow, and for diffuse lighting, you have a more gradual transition into shadow. So direct lighting, you can think of it as a sunlight or spotlight, anything that's producing a direct distinction between light and shadow. So the reason why we're dealing with this first is because I wanted you guys to know how to separate light and shadow first. Because in reality, this diffuse lighting will be a part of this direct lighting. So after we're done understanding how this direct lighting works, we're going to focus our attention on diffuse lighting. When you're painting something, the first thing that you have to think about or always keep in mind is form change equals value change. And it's really apparent here, or it's really obvious by transforming this smooth sphere into a planar sphere. And with this planar sphere, you can actually see the transition between each face of the sphere as it transitions into the shadow. Now this transition, this form change equals value change, doesn't really happen on a linear scale, meaning it's not happening on equal increments like this. So you have here a value scale that's separated into 10 equal increments starting from 100, 90, 80, 70, 60, 50, 40, 30, 20, 10, and finally 0. That's not what's really happening on a sphere or any curved object. What's really happening here on the sphere is something similar to this, a non-linear scale for the values. Okay, so meaning it's not really equal increments as it curves around the surface. Okay, so you have here this curvature, and each segment of this curve would represent a value. Now these values that you have here are not, again, they're not going to be on 10 equal increments. Okay, it's going to be something like this. Okay, so you have here the top plane is going to be around 90, and then this plane here 97, then 95, 94, 89, 84, 76, 65, 53, 36. Now the 36, this drop in value, this significant drop in value. Now you can see here at around this area, they're pretty close to each other. So there's, let's say, there's only a few gaps or three steps of value change in between. So you have here 100, 2 to 75. So you see this, you have 1, 2, 3, 4, 5, 6, 7. You have 7 steps, but the value change in between only happens on this area. So that's one thing you have to keep in mind. Okay? And then the actual transition happens, the actual gap or the actual obvious change in value, significant change in value happens around this area on the last second to the last step. Okay, so somewhere around here. And then finally, when it hits 0, you have your 0, 0. Now this value here, now this 0 here doesn't really represent 0 as in black. This 0 here means that this is going to be the area of shadow. Okay? Area of shadow. Now, this area of shadow can be darker or lighter than this black area, depending on the ambient light surrounding the object. But once you reach this part, this is going to be the area of shadow. So you're going to see it somewhere around this part. Okay, now on the setup, the light is coming from above. Okay, so obviously the planes that are directly facing the light source would be getting the most light, so it's going to be 100, or the lightest value possible for this object. And then the least amount, or as in no amount of light would reach that area, would be somewhere here. Okay, again, so you imagine light as a bunch of beams hitting your object. Now on this area here, nothing is hitting your object. It's curving away from from the light. And even if you have a plane like this plane here won't be hit by the light because they're parallel to each other. So if the light ray and the plane are moving on the same direction, they're parallel, they're going to be in shadow. Okay, they're going to reach this area here, black. Now, of course, here it's not black. Why? Because you have an ambient light hitting that shadow, that supposedly black area. Okay, and then in between these areas, as the plane changes, less and less of the light would hit each particular plane. Okay, and then that actually transitions into something like this, into a very very smooth object. We're just using this planar sphere to really emphasize that concept of form change equals value change. And then you always have to think about that on this area, you have to keep your values close because we're just dealing first and foremost is what we're dealing with light and shadow. So this area should read as light, and then this area should read as shadow. So think of it as a poster study of some sort. Okay, when you have established this boundary, when you find that tangent, only then can you provide transitions, subtle transitions in your sphere or any curved object. Okay? Okay, here's another example of showing that concept. So we have here again a sphere, and then we have a planar version of a surface of that sphere. And again, you can clearly see that on these areas, the values are pretty close to each other. So if I run across the surface using my color picker, okay, you can really see that it's not really changing much. The transition between each step is very very close to each other. You can only see the actual change around this part here. And then here is another example. Now this one has less steps in between, so meaning it's a less curvy surface, but you can clearly see again, this one here is directly facing the light source, so it's forming a 90-degree angle with your object, with your light source. So it's getting the most light. So you have here, it's around 86 of 86% bright. And then here you have another plane which is angled in a 45-degree angle. It's oriented like this. This one, this plane here is oriented on a 45-degree angle. And although it's a big big transition. It's almost rotating a quarter of the way. The transition between the values are very minuscule. Okay, but once you reach this angle here, okay, from 90, rotated another 90 degrees to reach this. So basically, you have a parallel surface with your light source. So what's gonna happen here is, look at this. From this angle, as it transitions to a plane that's parallel to the light beams, it becomes super duper dark. So meaning this is gonna be the value or the realm of shadow. And as you go down here, it's gonna be still in shadow because basically aside it's completely facing away from the light source. However, you can see it's a bit lighter than this one. Why? Because the light bounces as well. So this light here would go down here and then bounce back here to give it a bit of a light. But it's not gonna be super duper bright that it becomes distracting or it destroys the illusion of form. Alright? This secondary light, this bounce light is very very weak. So it's very subtle. If I color pick the two values, they're very close to each other. Okay? Now to further uh, for you to better understand what's going on here in terms of light beams, angles, and planes, this is the side view of this schematic. So we have your light beams, all right? So let's count how many light beams. You have one, two, three, four, five, six, seven. Seven light beams hitting an object directly, forming a perpendicular angle. Now, if we transfer those light beams on a surface that's on a 45-degree angle, you can see that there are only going to be five light beams that can fit inside this plane. So, meaning when there are less light beams, there's going to be less light bouncing on that object, meaning the values are going to be slightly darker. Very, very slight. And then as you transition on this plane here, which is parallel to the angle of the light source, nothing, no light beam is going to hit your object. Okay, so that's going to be shadow. And once again, on this surface here, the top plane here is going to be the brightest, and then as it goes down, as it reaches a parallel surface, you can see here how close they are to each other. This is going to be the shadow area. And when you really observe it, the shadows or the distinction between this value or the drop in value happens only in this area, and then these area these areas above are very very close to each other. So that's the thing that you have to think about. Okay, this non-linear transition into shadow. Now this idea of keeping your light values close to each other is very helpful in creating or rendering a sphere, a convincing sphere that's under direct light. Okay, we have here two examples. On the right here is a sphere that's rendered using a linear scale. So everything is evenly spaced down to the shadow area. What's gonna happen here is the sphere looks weird because there's poor separation between light and shadow, and it's starting to look more like a gradient pattern than an actual sphere. Okay, now on the other hand, the sphere here looks more convincing, looks like a sphere, a white sphere that's being hit by a direct light, because we're following a non-linear transition between the values. And if we really increase the contrast between these values, you can clearly see the separation between light and shadow. And if we do it on this sphere here, you can see how poorly separated shadows are. Okay, so this one is not how the shadow should be placed. It should be placed on this area here, because that's where the tangent is happening. So the important takeaway here is you find first where that shadow starts, and then you find the lightest part. Afterwards, you can do a gradual transition into shadow, and then uh, the obvious drop in value happens around the halftones. All right. Now that idea of separating light and shadow also applies to other curved surfaces. For example, the cylinder here. This idea of separating light and shadow is still a useful principle in rendering these kinds of forms. And then we have here on the right, this example here on the right is something that's rendered again on a linear scale. And the feel for this cylinder is it looks over rendered, okay? Because the values are not really compressed. It's not simplified. Everything is shown. Each step of the way is done linearly at equal increments. So it doesn't really properly represent our lighting scenario, which is a direct light. Direct light meaning there's going to be a distinct separation between light and shadow. Now, this idea also applies to cubes or other hard surfaced objects. Okay, you have here a side view of this object here. Now, I I did a different lighting scenario for this. Now, the light for this setup comes from this angle here, and then the shadows are going this way. When you're dealing with light and shadow, it's always important that you know where the light source is coming from and where the shadows would go. So that would orient where you would plot your shadows. Now here you can see that the top plane is not the brightest plane anymore. Okay, that honor goes to this plane because of the angle of the light. As you can see here, this plane here forms a 90-degree angle with the light source. Therefore, it's going to be the brightest among these light planes. Alright? Then the second one after this would be this one. And then another one would be, the third one would be this area. And these areas here are areas that are facing away from the light source. If I draw my light source here, you would see that this is getting hit at the top, but this area here is facing away from the light. Therefore, it's going to be in shadow. This area here, of course, is going to be in light as well because the light is oriented like this. It's hitting it on a quarter angle. So this is going to be still in light. But if this light here were to face this way at the back, this one would be in shadow because it's gonna form a tangent on that light beam. Now this time, the object is now lit from above, and as you can see here, the lightest part of the object belongs to its top plane, and then this area here would be the second lightest, and then as it falls down, it's gonna become in shadow. Same thing here. Alright, so every time that you're trying to render something from imagination or even from reference, always be mindful of these light beams because they would dictate where the light displays would be, where the areas of the shadows would be. So again, let's compare the two. So again, on an angled light source, this one is going to be the lightest part. Now it depends. If we slightly change, maybe slightly change that angle to something like this, it's still angled, but it's now going to favor this top plane. So the top plane would be again the lightest part. So again, consider the angle of your light source. Now you can see how the local value would affect the value changes on each cube. We have here on the right, you have here a white cube. This one is a gray cube. And on the left, we have a black cube. And you can clearly see the difference between each value transition. On the light plane, the white cube rather, you have here this value and then this value here, then finally this value. Alright, so you have 80, you have 68, and then you have 40. So let's write that down here. This one's gonna be 82. Let's say 80, okay? And then this one, let's say this is gonna be 60, 65. I'm just rounding them down so you can clearly see the gaps. And here it's gonna be around 40. Okay, so these transitions between each plane has a lot more gap compared to this one. So let's write this value here. We have 50, and then this one's gonna be, let's say, 35. Then this one's gonna be, let's say, 60. Okay, you can you can see that as you go darker, the transition between shadow, halftones, and light becomes more and more compressed. So here, you still have a lot to play around because you're starting from here and you have a lot of value to go with as you go down. And when you start from here, from this value, a midtone, you have less to work with, okay? Compared to the white, which compasses the whole thing. And as we go down here, you can see this one is 13, this one's going to be 11, and this one's going to be 8. You can clearly see that the gaps starting from here, you have around 22 value steps downward. So you have 80 down to 60, down to 40. Here you have around 15 steps, 15 to 35. And then as you go down here, you have 13, 11, and 8. The values are getting compressed as you change your local value. So that's something you have to keep in mind. A white sphere would have more contrast compared to a black sphere under the same lighting scenario. Alright? And another factor that affects how dark the shadows would be would also be the ambient light for your objects. Alright? So both of them look right, okay? They both look believable, although they have a difference in shadow. So if we mask this down, you can clearly see the difference between the shadows, the shadow values. Now what changed here is the ambient light surrounding the object. So there's no exact formula on how to render this. What's important is you know that the light source is going here, and as this plane faces away from our light, this one's gonna be in shadow, without a doubt. Now, the only thing that's gonna be open to adjustment is how light is it gonna be. And aside from this, you also have to consider forming or plotting the cast shadows. Now, you have identified that these are gonna be the borders for the shadows. What's left for you to do is determine how dark is it gonna be. Now, of course, these are heavily dependent on the surrounding factors on this object because again light bounces everywhere, and in the real world the light source is not going to be one single light, and from there to here maybe somewhere in between as well. So a lot of things happen, and what's really consistent along the way is the boundaries between light and shadow. So find where the shadows would be, and adjusting how dark it's going to be is just up to you, up to artistic interpretation.